Hello everyone, welcome to this tutorial on powers and roots. We're going to take a look at a couple of examples on powers first. Some of the more unusual ones that are a little trickier, not so unusual, but trickier to work with. What happens when you have a fraction inside a bracket that is raised to a power? Well, the first thing you have to do is take this a power and apply it to both the numerator and the denominator. So what we have here is 3 to the power of 4 divided by 4 to the power of 4. Now if we continue to simplify this fraction, we find out that 3 to the power of 4, in other words 3 times itself 4 times. 3 times 3 times 3 times 3 is going to yield 81. And we simplify the 4 to the power of 4, which means 4 is multiplied by itself 4 times. And that is going to yield 256. This is a rather large fraction, so we need to simplify this further if possible. And what we do is we find out that this is equivalent to 0.316. Alrighty, let's take a look at another example. In here, we're working with brackets again. We have to solve whatever is inside the brackets before we apply any exponent. Remember BEDMAS? Okay, so what do we do? Well, in this example, we don't know what x is. If x had been 3, for example, we would have done 2 times 3 to give 6, and then apply 5. However, we don't know what x is. So what do? We have to apply the exponent to each of the elements inside the brackets. So in this case, you're going to have 2 to the power of 5 times, because that's what's happening here, 2 times x, times x to the power of 5. Now we have to continue to simplify. What is this going to equal? Well, we can do 2 to the power of 5. 2 multiplied times itself 5 times is going to yield 32. Now we multiply that times x to the power of 5. We don't know what x is, so we simply multiply it directly beside. You could put the multiplication sign, you could just leave it right beside it. And that means we have now simplified 2x to the power of 5 yields 32x to the power of 5. Okay, what about division of powers? When you're about to divide powers, in our example we've got a to the 6th. It looks like subtraction, but it isn't. It just copied over that way. A to the 6th times b to the 4 times c to the 5 divided by a to the 3 and b to the 2. What happens? When you have exponents with a common denominator and a numerator, then what you can do is subtract the denominator from the numerator. So what we end up in this case is a to the power of 6 minus 3 times b, oh look, we can do this one too, b to the power of 4 minus 2. Now c, there is no denominator for c, so we simply multiply both of these times c to the power of 5. We have now eliminated the denominator. We've subtracted it from the numerator, and we've solved for this expression. Okay, here's one that's a little trickier. What happens when a power is 0? Well, the answer is it doesn't matter what you are multiplying in the fractions in here, or whether it's a fraction, a number, anything inside this bracket, or any number raised to the power of 0 will always be 1. Now, that's kind of hard to wrap your head around, so let's take a look at why that is. Any number divided by itself will always be 1. 2 divided by 2 is 1. 3 divided by 3 is 1. And so on. So let's just write that down. 2 divided by 2 equals 1. Okay, so we can say any number divided by itself or any value divided by itself will equal 1. So that means if we said x divided by x, it is also going to equal 1. Okay, let's take this one step further. X divided by x is also x to the 1 divided by x to the 1, because x to the 1 equals x. All right, we now know from how to handle division of powers that we can take this expression and it's going to equal x to the 1 subtract 1. You with me? Where are we going? 1 subtract 1 is 0. So this expression equals x to the power of 0. All right, let's look at all of these expressions. They are all equal to each other. So that means x to the power of 0 also equals 1. So any number raised to a power of 0 will always equal 1. Little hard to wrap your head around that one, but if you spend some time working through examples like that, you'll see that it'll always come out to 1. Okay, let's move on to taking a look at roots. In here we have an expression with this little sign here, and that sign is called a radical, and it expresses the root. Roots are the exact opposite of powers. So what does all of this mean? What we're trying to do here is determine the square root of 16. And what do I mean by square? Square is the equivalent to the number 2. So if you ever see anything in this position right up in here, that position is called the index. It doesn't have anything in it, but that means by default that it is 2. 2 is the power, right? And this is the radical. They are opposite of each other. One has a power, one is a root. They are going to cancel each other out. So we don't see a 2 in here if we are trying to figure out the square root. So the square root of 16, what we're trying to do is determine what number multiplied by itself only once, because it's squared, equals 16. So let's go through it. 1 times 1, no. 2 times 2, that's 4. 3 times 3, 9. That doesn't work. But 4 times 4 is 16. The square root of 16 is 4. Let's look what the power would look like. We would be saying 4 to the power of 2, which is equal to 4 times 4, which is equal to 16. See how that index is 2? See how the 2 cancels out the radical to yield the 2 doesn't cancel out the radical. The 2 replaces the radical, and you end up with the square root of 4. All right. B, let's take a look at when we have a square root of x to the power of 2. Here's what I was talking about earlier. You've got the implication that this is 2. What we can do is say that the index is going to cancel the power. They are direct opposites of each other. They are going to cancel each other out. What you are going to get left with is simply x. Want to take a look at an example of this. If we had 3, the third root of 2 to the power of 3. The power and the index will cancel each other out, leaving you with 2 as your answer. So let's test that. If we have 2 to the power of 3, what we're saying is 2 times 2 times 2. You can see the third root has to be 2. All right, expressing roots in exponential form. Here we've got the square root of 81 showing. So what number multiplied by itself is 81? Now let's go back to the assumptions. We don't have a number up in here, so the index has to be 2. 81 without an exponent is actually 81 to the power of 1. Remember, roots are the exact opposite of powers. So what we're really saying here is that we have 81 to the power of 1 over 2. You think of powers in multiplication, you think of roots as division in an exponential format. All right, let's take a look at this one. Here we have a different power than we will have on the index. The index is nothing on there, so the implication is that it's 2. How do we express that in exponential form? You're going to have x. Remember, it's going to look like a fraction, so we're going to have the power on the numerator, which is 3, over the index of 2. And that's it for this tutorial on roots and powers.